This lesson is for Mrs. Cucci's College Now College Prep Math class. We are on lesson 3.5, and we're going to be talking about quadratic equations today. So the first thing we need to talk about is binomial. Binomial, oops, use a pen, is a simplified algebraic expression that contains two terms in which each exponent that appears on a variable is a whole number. So the first thing we're going to be talking about is how we multiply together two binomials. And the method that we're going to use for multiplying binomials is FOILing. And you've done this before, this isn't new. So FOILing, FOIL stands for F as in first, O as in outer, right, F, O, I as in inner, and L as in last, F-O-I-L. So that's the order in which we're going to multiply. So my first term's x times x, which is x squared. X times a positive 4, which is 4x. Positive 3 times x is a positive 3x. And the last positive 3 times positive 4 is a positive 12. We're going to combine those center terms. They're like terms. 4x plus 3x is 7x. And there you have it. Okay, let's try the next one. So again, we're going to be using FOILing. First, 3x times 5x, 15x squared. Outer, 3x times negative 3x, or 3x times negative 3, sorry, is negative 9x. Inner, 4 times 5x is 20x. And last, 4 times negative 3 is negative 12. The next thing we have to do is we have to combine my center terms, my like terms. 15x squared doesn't have a like term, so that stays. And this becomes positive 11x. Negative 9x plus 20x is positive 11x minus 12. So now what we're going to do is we're going to work in the opposite direction, and we're going to start factoring these trinomials. Okay? So we have a couple rules that go along with this. This last number here, it has to multiply to be 8 and add to be 6. Okay? If this sign here is plus, both signs are the same. And then you look here, and in this case, it's going to be positive. So when you start setting this up, you're going to have two sets of parentheses. You know you're going to have plus plus. Signs are the same, they're both going to be positive. You know you're going to have x and x. X times x is going to give you x squared. So two numbers that multiply to be 8 that add to be 6, so I start thinking about my factors. 8 and 1, 4 and 2. Well, I know 8 and 1 is going to give me 9. That won't work. But 4 plus 2 will give me 6. 4, 2. And that's factored. Two numbers that multiply to be 8, add to be 6. 4 and 2. Signs are the same. They're both going to be positive. Let's try another one. Okay, same thing again. Two sets of parentheses. I know I'm going to start with x and an x. The signs are not going to be the same. This time they're going to be different, so it's going to be plus and minus. So I need factors of 35 that are going to add to be a positive, factors of negative 35 that are going to add to be a positive 2. Okay, factors of a negative 35 that are going to add to be a positive 2. So 7 and 5, negative 7, positive 5. But that's going to add to be a negative 2. 7 and negative 5 will give me a positive 2. So 7, positive 7, negative 5. Okay, that one rejected because it gave me a negative. All right, so these you've done before. You've also done something called AC method. So that's where we're going to be going with this one. Okay, when you have that leading coefficient that's greater than 1, you use AC method. All right, so A times C is going to be 3 times 28. 3 times 28 gives me 84. So we need factors of 84 that are going to add to give me 20, negative 20. Factors of 84 that are going to add to give me negative 20. So I need to start finding factors of 84. So I know 42 and 2, but that's not going to give me 20, so that's not going to help. Negative 42 and negative 2. I divide it by 4. 84 divided by 4. It's going to give me 21 and 4, but that's not going to give me it. So let's try 6. 14, negative 14, and negative 6. Well, that'll add to give me a negative 20. So if you remember, we took this center term and we split it up. 3x squared minus 6x minus 14x plus 28, right? We split it. Negative 6x minus 14x gives us our negative 20 back, but it allows us to do that factor by grouping, to look at that first half and the second half. Okay? Pull out your GCF in the first half, which is 3x. It's going to give me x minus 2. Pull out the GCF in the second half, negative 14. Remember, you always have to wind up with both of these sets of parentheses being the same thing. Okay? What sits out front? What they have in common. And that's in factored form. Okay, so we're going to try the same thing with the next one. We're going to use AC method again. 8 times negative 3 gives me negative 24. Any factors of negative 24 that are going to give me negative 10? 12 and negative 2 will give me a positive 10. Negative 12 and 2 will give me a negative 10, so that'll work. So we split this center term. Okay, so now that you have that center term split, you need to look at the first half and the second half. And start by taking out your GCF. So in the first two terms, our GCF is a 4 and a y. So what goes in the parentheses? 2y minus 3. In the second half, you don't have a GCF, so all you're going to be able to do is take out a 1, which is still going to leave you with that 2y minus 3, which is what we want. So what sits out front? 4y plus 1. And what they have in common? 2y minus 3. So now that we've reviewed factoring these quadratics, we're going to go ahead and we're going to solve the equation after factoring using the zero product rule. Okay? So x minus 5, x minus 2 equals 0. This is nice because it's already in factored form for us. So we can go straight from here to the zero product rule and take each factor and set it equal to 0. From here, we're going to solve. We add over the 5 and add over the 2. So our solutions are 2 and 5. So if it's already factored for us, it's really simple. Most times it won't be. Okay, so if we look at the next one, this one's obviously not factored for us. In order to even start this one, I have to make sure that it's first set equal to 0. So we need to go ahead and move that 35 to the other side where everything else is. So we're going to subtract that 35 over. Once it's set equal to 0, I can go ahead and factor this. So again, these are like our basic ones. Our leading coefficient is 1. So we're going to go ahead and split it up into 2 sets of parentheses. X and X. Signs, if you look here, signs are going to be different. So plus and minus. Need factors of negative 35. They're going to add to be negative 2. So 7 and 5. I make this negative and this positive. That'll work. Once I have it factored, I set each factor equal to 0, and I solve for x. And I have my solutions. Okay, so now let's get a little bit more difficult. This is the quadratic equation with a leading coefficient other than 1, so we are going to have to use the AC method. A times C is 5 times 40, which is going to give me 200. So I'm looking for factors of 200 that are going to give me negative 33. Okay, factors of 200 that are going to give me negative 33. So I have to start finding factors of 200. So 20 and 10, but that's going to give me negative 30, so that's not going to help me. $25 and 8. Now that will give me negative 33. And all I did to get these is I just started dividing 200 by something to give me something to work with. Okay, so we're going to split up that center term. We're going to keep our 5x squared minus 25x minus 8x plus 40 equals 0. First half, second half. GCF in the first half is 5x, which is going to give us x minus 5. GCF in the second half, remember, it has to be x minus 5. So I'm going to take out a negative 8. What sits out front? What they have in common. Now that it's fully factored, I can use zero product rule and set each one equal to 0. And go ahead and solve. So I get 8/5 and 5. All right, so the last thing I want to talk about is something called the quadratic formula. The quadratic formula is a formula that will allow you to solve any quadratic if it doesn't factor. Even if it does factor, the quadratic formula will solve any quadratic equation. Okay, so the formula is going to have to be memorized. So here it is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, you can sing, if you sing it to a song, it helps you remember it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I think it's like Pop Goes the Weasel, but that'll help you to remember it. And you get those values of a, b, and c from here. Okay, ax squared plus bx plus c. So whatever's in front of the x squared is your a, whatever's in front of the x is your b, and the constant is c. All right, so let's actually solve one out. So I'm not going to factor this one, I'm going to use a quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So a is 2, it's whatever's in front of the x squared. B is 9, it's whatever's in front of the x. C is negative 5, it's your constant. So we're going to plug those values in. Negative 9 squared minus 4 times 2 times negative 5 all over 2 times 2. So it's just substituting in those values. Now we're going to go through and we're going to determine what this is. 81, 9 squared is 81. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is positive 40 over 4. Negative 9 plus or minus 81 plus 40. 121 over 4. Come up here. Square root of 121 is 11 over So you actually break this up into two. Negative 9 plus 11 over 4 and negative 9 minus 11 over 4. They're two different solutions. Negative 9 plus 11, or 11 minus 9, you could say either way, is 2/4, which is 1/2. So that's one solution. And the other solution, we get negative 20 over 4, which is going to be negative 5. So my solutions are 1/2 and negative 5. So the quadratic formula will solve any quadratic equation that you give it. If you can't factor it, you can solve it using quadratic formula. All right, so let's try this one. Now this one, in order to solve it, we have to get it set equal to 0. So we need to move everything here to the left-hand side of this equation so we can do that. So we're going to subtract over the 4x, and we're going to subtract over the 1 so that it's set equal to 0. Now, we're going to use our formula. A is 2, B is negative 4, and C is negative 1. So we're going to go ahead and plug those in. Negative 4 becomes a positive 4, right? If I plug in a negative here and I have a negative out front already, it becomes positive. Negative 4 squared, notice I'm putting it in parentheses. Minus 4 times 2 times negative 1, all over 2 times 2. So let's do some simplifying out here. Negative 4 squared is 16. Negative 4 times 2 is negative 8, times negative 1 is positive 8. Plus 8 is 24. Okay, so we have two solutions, 4 plus radical 24 over 4 and 4 minus radical 24 over 4. Now if you remember from doing radicals, this can be simplified. We can simplify square root of 24 into 4 and 6, or 2 square roots of 6. Okay. Or you can write it like this. You can divide all of these by 2, right? This can be divided by 2, this can, and this can. You can write it as 2 square roots of 6 over 2. 2 minus square root of 6 over 2. That's just simplified. Okay? And there you have it. Okay. Blood pressure and age. All right, so the equation P equals 0.006a squared minus 0.02a plus 120 models a man's normal systolic pressure P at age A. Find the age to the nearest year of a man whose normal systolic blood pressure is 125. All right, so if his pressure is 125, we need to substitute that 125 in for P. Okay. So the next thing I need to do is I got to get this set equal to 0. I need to solve this, but in order to solve it, I need to get it set equal to 0 first so I can use the quadratic formula. So we need to move this 125 over. Okay. Now I can use my quadratic formula to solve. Okay. A is 0.006, B is negative 0.02, and C is negative 5. X equals negative negative, so it becomes positive. So all I'm doing is substituting in right now. Okay. You're going to use your calculator to determine that value underneath the radical. All right. Now I'm actually going to split this up into two, one plus and one minus, and put it right in my calculator to see what I get. So 0.02 plus the square root of 0.1204 divided by 0.012 is going to give me 30.5823. 0.02 minus the square root of 0.1204 divided by 0.012 gives me negative 27.2489. Okay, and if you're looking for the age of a man, you're not going to have a negative age. So we're going to say he's about 31 years old. Okay, and that's it, guys. That's the end of the unit. Make sure you do the practice and then you get the review done. And I will see you tomorrow.